This is a video about how to prepare a haloalkane in the lab. A tertiary haloalkane can be prepared from a tertiary alcohol by using concentrated hydrochloric acid. Tertiary means the carbon atom bonded to the functional group is bonded to 3 other carbon atoms in the molecule. In this example, we're going to use methylpropantuol to prepare 2-chloromethylpropane, the haloalkane. Here's the method. The alcohol is added to a separating funnel, and then concentrated hydrochloric acid is added and swirled. Occasionally the stopper is released to release any gas that might be given off. The alcohol is soluble in aqueous acid, so one layer is formed. However, after a while, 2 layers form because the haloalkane is insoluble in the aqueous layer. Sodium hydrogen carbonate is added once the reaction is finished to neutralize any remaining HCl, and then the aqueous layer is run off. This process is repeated a few times, and finally water is added and shaken with the haloalkane, and then finally that layer, the aqueous layer, is discarded once more. So we're left with the insoluble haloalkane layer. The haloalkane is then transferred from the separating funnel into a small flask. At this stage we add a spatula of anhydrous magnesium sulfate to the flask and swirl it. Anhydrous magnesium sulfate is very good at absorbing any water. It won't dissolve in the haloalkane. It'll just sink to the bottom as a white powder, but it'll absorb any water present. So the next step is to filter off the magnesium sulfate. So we're left with a reasonably pure haloalkane. There will be a little bit of the alcohol still present in it, unreacted alcohol. So we need to distill the haloalkane to ensure we have a pure product. And we do this by distillation, because the haloalkane has a lower boiling point than the alcohol. The haloalkane boils at 51 degrees Celsius, whereas the alcohol boils about 20 degrees higher than that. Let's look at a video showing the process.
This is the synthesis of a liquid organic product. Today we're going to synthesize 2-chloro-2-methyl-propane. Add 30 centimeters cubed of concentrated hydrochloric acid to a conical flask in an ice bath. And put the stopper on and leave it to cool. The hydrochloric acid has now been on ice for about an hour, and we're going to add 2.5 grams of calcium chloride to this acid. Next add 10 centimeters cubed of 2-methyl-propan-2-ol. And then mix thoroughly. Leave the flask out of the water bath to get slowly to room temperature. You may need to take the cork off now and again to relieve any pressure from gas. Transfer the mixture to a separating funnel. Invert this a few times to mix it. Remember to release any pressure formed by gas. You now need to run off the aqueous layer. The mixture is separated into 2 layers. You have this cloudy layer at the bottom and this clear layer that we've marked with pen here. If you add water to it, you can check which is the aqueous layer, because that will be the one that grows in volume. So as you can see, this bottom layer is the one that has grown in volume, and that's what we're going to run off now. So you run it off by turning the tap. I'm now going to add 10 centimeters cubed of sodium hydrogen carbonate to the solution to wash it. Cool. The gas formed is carbon dioxide. As you can see, it'd be better if I added that slowly. You now want to put the stopper in and invert it. And remember to take the stopper off, because the gas will be formed all the time. Once again, you want to run off the aqueous layer. You can see it separates into this clear layer and a cloudy layer on top. You repeat this process once more using sodium hydrocarbonate and then using deionised water. Collect your final product in a clean, dry conical flask. Add magnesium sulphate to the solution, and you want to swirl it to mix it gently. You want to keep adding it until no more clumps form. Magnesium sulphate is a drying agent. It's trying to remove any excess water from the solution so you don't have it in the final product. Filter your product into a round bottom flask. The filter funnel has been filled with cotton wool. Fill the product in a water bath. The product boils at 69 degrees centigrade, so we set the water bath at 70 degrees centigrade so we don't overheat it. We'll make a note of the temperature when it does distill. We've now finished distilling the product, as you can see. We've not got very much product, but it was very pure. It did come off at 69 degrees, but our yield will be very low. You can measure the yield